look at pressure, then we'll now talk about temperature. Okay, let's look at pressure. Now, considering effect of change in pressure now, effect of change in pressure on equilibrium. That's what we are looking at, on equilibrium. So let's look at example here, example of a reaction. Now we can use this reaction because it's a gaseous system. So that tells us that change in pressure affects only what? Affects only a system that is what? That is gaseous. That simply means a system in which either the reactant or the product is what? Is a gas. It's called a gaseous what? A gaseous system. So this system is at equilibrium now. We have forward reaction and we have what? Backward reaction. So we want to see what's going to happen if pressure is increased or what? Or decreased. Now, before we can look at that, we must establish some facts here. Like I said earlier, number one, change in pressure affects only what? Change in pressure affects only a gaseous what? A gaseous system. And what's a gaseous system? A system in which either the product or the reactant or both are what? Are gases. Okay, then number two, change in pressure, okay, will affect a reaction in which the number of moles of reactants, okay, is not equal to the number of moles or what? Moles of products. Very important that you get this. Okay, for pressure to work, pressure only works in a reaction in which the number of moles of reactant is not equal to the number of moles of product. For example, if you look at this system that we are looking at here, the number of moles of nitrogen is 1, number of moles of what? Of hydrogen is 3. Okay, number of moles of ammonia here is 2. So here we can see on the reactant side we have 4, and 4 is not equal to 2. So that tells us that change in pressure will affect equilibrium in this system. Change in pressure will affect equilibrium in this what? In this system. Okay, so if you have a system like this, maybe a reaction like reaction in which you have your iodine reacting with your hydrogen to form hydrogen iodide. This kind of reaction, number of moles here is 2 because I have 1. Number of moles here is what? Is 2. Balance equation. So you can see the two of them are the same. They are equal. So since they are equal, change in pressure does not affect this kind of reaction. Change in pressure does not affect this kind of reaction. Okay, I hope you got the clue. Okay, so basically I have 4 moles here, I have 2 moles. Now, another point that I need to explain, to lay the background for change in pressure is this. You must know how pressure develops in gases, how gaseous system or a system that is closed, a closed system involving gases, and how pressure arises in a closed system. You should know the definition of pressure. That pressure is force per what? Unit what? Area. Okay, so if I want to ask you the question, how does pressure develop in a gas?
So it's like pressure is force over area.
Yes, so how does pressure develop in a gas? Let's assume that I have a system like this. This is a container that containing gases. Okay, let's say the gas, I have hydrogen there, I have nitrogen, the gas is gaseous molecule. Yeah. So how will pressure develop inside this container? How will pressure develop?
So them hitting the walls of the container.
Thank you. So each of these molecule will bombard, they will hit the wall of what? Of this container. So they will hit the wall of what? Of this container. That's how pressure what arises in gases. Okay, so pressure arises when the gases bombard, okay, bombard with one another, okay, and the wall of the what? The container. Okay, so that is one point there. Now, secondly, is there any connection between, how do you think I can increase the pressure inside this container without tampering with the temperature? How can I increase the pressure in this container?
So by increasing the number of molecules.
Fantastic. Yeah, I feel like ordering you a pack of pizza. Yeah, that's fantastic. Yeah. So if you increase the number of molecules, you increase the pressure. That tells us that increase in number of what? Molecules, which is we call like moles. Increase the number of molecules will lead to what? Will lead to increase in what? Increase in pressure. Okay. So if I want to increase the pressure, I will put in more molecules. If I want to decrease the pressure, what will I do? I will take out molecules from it, isn't it?
Yeah.
Good. Good. So let's now look at this system that we cited earlier here. So we have said that we have been able to establish the point that under this number 3, that the more the molecules, the more the molecules, okay, present, the more the what? The more the pressure, or the higher the pressure, okay? The higher the pressure. Good. Now let's come back to this. We have established some very important points. So let's come back to this particular factor here. Effect of change in pressure on equilibrium. So when it comes to pressure, you cannot increase pressure of reactant alone or increase pressure of product alone. No, because everything is together in a single container, in a closed system. So when you increase the pressure, you are only increasing the pressure of the system, everything together, both reactant and product. When you decrease the pressure, you are decreasing the pressure of the system altogether, both the reactant and the what and the product. Okay, so having established that, let's see if I increase pressure. So let's say increase in pressure. That is what I did to alter equilibrium. I have altered equilibrium by increasing the pressure of the system. So what will equilibrium do? Le-Chatelier's principle tells us that equilibrium will attempt to reduce the pressure. Now, how will equilibrium attempt to reduce the pressure? I want you to suggest. How will equilibrium attempt to reduce the pressure?
By moving to the place with less molecules.
Okay, fantastic. So equilibrium will attempt to reduce the pressure by favoring the side with lesser molecule, because what that simply means is that 4 moles, anytime 4 moles is used, it's going to reduce to what? To 2 moles. So as equilibrium is favoring the forward direction, more molecule is being used up to form less molecule. So more of nitrogen and hydrogen will be used to form less of what? Ammonia. So the direction is I'm converting 4 to 2. I'm converting 4 to 2. So equilibrium favors the side with lesser what? Lesser moles. Okay? Equilibrium favors the side with lesser moles. So let's see how we write that down. So increase in pressure will force equilibrium to what? Equilibrium favors what? Favors the forward what?
Yeah.
Equilibrium favors the forward reaction, right? Equilibrium favors the forward reaction, or you say equilibrium shifts to the what? equilibrium shifts to the right hand side, right? Equilibrium shift to the right hand side. That's another way to say it. And when that happens, you say that there is more what? More yield. So you say there is more yield of what? More yield of ammonia. That means there is more yield of ammonia, more product. Here, more yield of what? Of ammonia. You got that? That's how pressure works. The moment you are able to follow the three fundamental issues that I raised earlier, you'll be able to get your pressure. So let's now look at another point here. Okay, if I decrease the pressure, decrease in pressure. Okay, decrease in pressure. Now, this does not mean that for all reaction, increase in pressure will favor the for all reaction. No, you have to look at the stoichiometry of the equation and see where you have more moles and where you have lesser moles. Okay, so increase in pressure, can you state what equilibrium will do?
It will move to the backwards reaction.
Okay, so equilibrium favors what? Equal. Let me just use shorthand form. Equilibrium, okay, favors what? Favors the what?
The backwards reaction.
Backward reaction. The backward reaction. And that simply means less what? Less yield of ammonia. Less yield of what? Of ammonia. Yeah, because we'll need to later relate this to Haber process and what? And contact process. Okay? Haber process and what? And contact process. So equilibrium favors the backward reaction, and that's simply less what? Less yield of what? Of ammonia. Okay, so basically that is how pressure affects the what? Affects the position of what? Position of equilibrium. So the most important thing is, number one, just to recap this, you need first to find out whether the system is a what? Is a gaseous what? Is a gaseous system. Okay? Find out if the system is a gaseous system. If the system is a gaseous system, that means there is possibility that change in pressure will affect the what? The system. Number two, find out if the number of moles on both sides are what? Are equal. If the number of moles on both sides are what? Are different, then definitely change in what? In equilibrium will affect the system. But if the number of moles are the same, change in equilibrium will not what? Will not affect the position of what? Position of equilibrium. And in your explanation, okay, you are going to relate that to side that has more moles and side that has what? That has lesser what? Lesser mole. Okay, that's the way to look at that. Okay, we'll relate this to the manufacture of ammonia later. Manufacture of ammonia and the manufacture of what? Of sulfuric acid. Okay, so I think you got this. Let's go to ahead to look at temperature. How temperature affects the what? The position of equilibrium. Okay, can we go to temperature?